Okay, hello class. Today we continue to subtopic t-test. Okay, for t-test, you may refer to the note, the condition or the situation when we need to use t-test is, okay, only one condition or one situation. Okay, small sample. Small sample means your data less than 30 and less than 30. This is small sample, and then plus another one condition is S sample. S sample. What is S? S is standard deviation from sample. Standard deviation from sample. Okay, this is the condition when you need to use t-test. Okay, so the test statistic for the t-test is test statistic. Okay, T equal to X bar minus mu. Okay, divide S over square root N. Okay, this means t-test T. Okay. Okay, I give a sample how to find the critical value for the t-test. Okay, so you need to start with HO and H1, H0 and H1. Okay, for H0, for example, mu equal to 20. Okay, and for H1 is mu more than 20. Okay, and you also have HO mu equal to 20 and H1 mu less than 20. Okay, symbol more than and less than. Okay, when to use more than, you may refer to the question. Also for less than, but for the H0 equal must be used equal symbol. Equal symbol. Okay, this one value of 20, I just give an example for you. This is depends for your question also. For 2020 the value here. Okay, and then significant level. Okay, significant level means the value alpha given in the question. Okay, for example, alpha is 0.1. Okay, same here, significant level alpha equal to 0.1. Okay, and then critical value. Okay, critical value is the value that we need to read from table. Okay, for this t-test, to read the value, you are given t-table, new t-table. Okay, this is the t-table. Okay. Okay, so how to read t alpha n minus 1. Okay, in your note, it given to you t alpha over 2. Okay, so make a correction for your note, not t alpha over 2, but only t alpha. Okay, I repeat again. In your note given before, the alpha is over 2, but the correct answer here only t alpha. Okay, n minus 1 same. Okay, so here t alpha is 0.1 Okay, n minus 1. Okay, for example, you have data 9. Sorry, you have data 10. So, 10 minus 1, 9. Okay, here. T 0.19. How to read the value T 0.19 from table T? Okay. Okay, on top here, you are given the value of alpha. Okay, so 0.1, 0.05, 0.025, 0.01 and 0.05. Okay, so you need to use 0.1. Okay, and n minus 1 given is 9. 9. Okay, 9. So 0.1 for alpha and the n minus 1 is 9. So the correct answer is 1.383. Okay, 1.383. 1.383. Also make a correction for your note. The correct answer is 1.383. Okay, and then for critical value, you must give the symbol positive or negative. Okay, so this is more than. So, the critical value here must be positive. Okay, and then for critical value here, okay, same T alpha n minus 1. So, T 0.1, okay, n minus 1, same 9. Okay, the answer is 1.383. Okay, but the symbol here, because this is less than, so the symbol here is negative. Okay, same, make a correction for your note. This one only alpha and the answer is negative 1.383. Read the value from table. Okay, and then for decision rule. Okay, for decision rule, okay, you must reject H null, H0 if T calculate. T calculate means the T statistic more than. Why more than? Because your H1 is more than. Okay, more than T table. Okay, T table means T critical value here. You must reject if more than. And for this condition, if less than, the decision rule equal to reject H null if T calculate means T statistic less than. Why less than? Because your H1 is less than T table. T table is T from critical value. Okay, this is explanation for the T test. Okay, next I continue to example 1. Okay, for example 1, same. You need to identify the sample data, how many n given and the standard deviation given. Okay, so example 1, a manufacturer claims that the mean lifetime of its watch is more than 10.5. Okay, 10.5 years. A sample of 10 watch tests reveal a sample mean of 10.5 years with a standard deviation of 0.09 years. So, a sample of 10. A sample of 10 means your n. N equal to 10. So, you identify this sample 10 is less than 30. So, it means this is a small sample. Okay. Reveal a sample mean of 10.58 years. Okay, it have the sample mean. So this is the X bar, 10.58 years. With a standard deviation. Okay, read carefully. A sample of 10 with sample mean of 10.58 years with. It mentioned with a standard deviation. Means this is from sample. Okay, from sample and equal to 10. So this is S, standard deviation from sample. This is standard deviation from sample. Okay, so standard deviation from sample given 0.09. 0.09. Okay, so the n is small sample and you have standard deviation from sample. So your test statistic is t-test. Okay, so you must use t equal to x bar minus mu over s divide square root n. Okay, next we write the test hypothesis testing. Okay, so start H0 and H1. Okay, so what you need to test is claim that the mean life of its washes is more than 10.5. Okay, so your mu is equal to 10.5. Okay, and more than, this is for H1. So mu more than 10.5. This is the H1 more than it mentioned. Okay, so using 1% significant level, test the claim. Okay, so it given to you the significant level. Okay, significant level alpha equal to 1%. 1% means 1 divide 100. 100. So 1 divide 100 is 0.01. Okay, so the next step is test statistic. Okay, test statistic here, t equal to x bar minus mu divide s over square root n. Okay, you substitute the value. The x bar is 10.58 minus the mu is 10.5. Okay, divide s 0.09 over square root n. N is 10. Okay, then you calculate. Okay, so after you calculate, the final answer is 2.81. 2.81. Okay, so the next step after test statistic is you find the critical value. Okay, for critical value, so T alpha, comma, and minus 1. Okay, so T alpha 0.01 and your N is 10. So 10 minus 1 is 9. Okay, so T 0.019. Okay, read the value from T table here. Okay, so find 0.01 on top here. So 0.01 is here, 0.01, and then you find the value of 9. Okay, on your left here, 9. So the answer from table you read is 2.821. Okay, so 2.821. Okay. Okay, and then don't forget to give the symbol for your critical value. This is more than here for the H1. So the critical value is positive value here. Okay, next, the next step is decision rule. Okay, what is the decision rule? Okay, reject H null if T calculate more than T table. Okay, T calculate means the T statistic here more than. Why more than? Because your H1 is more than. Okay, and T table is T from critical value. And then we continue to the decision. Okay, what is the decision? Decision is the compare. You compare the value of T test with the value of critical value. Okay, so the T test, the value you done calculate is 2.81 and the critical value here is 2.821. Okay, compare the value 2.81 and 2.821. Okay, the value is less than. This one is 81, but your critical value is 82, so less than. Okay, so you reject H null if more than. This one is less than, so the decision is do not reject H null, H0. Okay, do not reject H0. Okay, and then you can make a conclusion. Okay, because you do not reject the H null, so there is no sufficient evidence to conclude that the mean lifetime of each washes is more than 10.5 years. Okay, this is the conclusion. There is no sufficient evidence. Why no sufficient evidence? Because you do not reject the H0. Okay, so finish for example 1. Okay, next I continue to example 2. Okay, for example 2, a business school claim that students who complete a 3-month typing course can type on average less than 1,200 words an hour. A random sample of 25 students. Okay, so this is the N. Random sample 25 students. So 25 student is less than 30, so this is small sample. Okay, who complete this course type on average 1125 words an hour. On average means the X bar. So the X bar given is 1125. With standard deviation of 85 words. Okay, so this is standard deviation from sample, so this is S, so the S given is 85. Okay, assume that the typing speed for all students who complete this costs have approximate normal distribution using the 5% significant level, can you conclude that the claim of the business school is true? Okay, before we proceed to the hypothesis testing, you must find the test statistic here. So you need to use test statistic for the condition small sample and the standard deviation from sample. So you use t-test. Okay, so t equal to x bar minus mu over x divide square root n. Okay, so we continue to the hypothesis testing. So H0 and H1. Okay, so what is H0 and H1 from this example? Okay, claim that student who complete a 3 months typing course can type on average less than, okay, so less than 1200. So your H null here is mu equal to 1200. So less than, the symbol is less than 1200 for the H1. Okay, next we write the significant level given. Okay, for this example, the significant level given is 5%. So alpha equal to 5 divide 100 is 0.05. Okay, next test statistic. Okay, test statistic, you use here t equal to x bar minus mu divide s over square root n. Okay, x bar, substitute the value 1125. Okay, minus mu 1200 divide s 85. Okay, and then over square root n 25. Okay, then calculate. The final answer for here, for test statistic here is negative 4.41. Negative 4.41. Okay, next we continue to the next step is to find the critical value. Okay, critical value means you find the value from t table. Okay, critical value, so t alpha and minus 1. Okay, alpha is 0.05, your n minus 1. Okay, the data is 25 minus 1 is 24. Okay, so read the value from table. You find on the top 0.05. Okay, 0.05 here. Okay, and then you find the n is 24. N 24. N 24 here. So the answer from table is 1.711. 1.711. Okay, but don't forget to give the symbol for your critical value here, positive or negative. Okay, you refer to the H1. Your H1 is less than, so your critical value here must be negative 1.711. Okay, next step is the decision rule. Okay, decision value for this example is you reject H null if T calculate T table. Okay, what is the symbol here? because it's less than, so the symbol here also less than. You reject H0, H0 if less than T table, means T calculate, T statistic here less than T table, T from critical value. Okay, next we continue to the decision to compare the value from T calculate and T table. Okay, decision. Okay, so the T calculate, you calculate is negative 4.41 and T table negative 1.711. Okay, compare the value. Is it less than or more than? Okay, negative 4.41 is less than. Okay, less than negative 1.711. So if less than means you need to reject. Reject H0. Okay, and then you make the conclusion. Refer to the claim. What is the claim of the business school is true? Can you conclude that the claim of the business school is true? Okay, so because you reject, so the conclusion is there is sufficient evidence to conclude that, okay, mention what is the claim. Okay, that the student who complete a 3-month typing course can type on average less than 1,200 words an hour. Okay, complete. You must state the claim. What is the claim? Okay, so the claim is the student who complete a 3-month typing course can type on average less than 1,200 words an hours. Okay, this is for example 2. Complete for example 2. Okay, next I continue to example 3. Okay, for example 3, a series of intelligence tests found that the average score among undergraduate students is 100 points. The following sample is the IQ score for undergraduate students at a certain university. Okay, this is different from example 1 and example 2 because in this example you are given the data. Okay, you are given the data. The data is 110, 118, 110, 122, 110 and 150. So the question asks you, at one significant level, are the undergraduate students smarter than the population average? Okay, so first you need to identify the N and the standard deviation. Okay, so how many data given? 1, 2, 3, 4, 5, 6. So you have N equal to 6. Means less than 30. This is small sample. Okay, but you are not given the X bar and the standard deviation from this sample. Okay, so what to do is you need to calculate the X bar and the standard deviation using ungroup data, mean and standard deviation using the formula of ungroup data. Okay, this is from chapter measure of central tendency. Okay, so how to calculate X bar means how to calculate the mean, sum X divide N. Sum X means total X. Okay, how to calculate total X? 110 plus 118 plus 110 plus 122 plus 110 plus 150. So the total X is 720. And then you divide N. N is 6. So your X bar is 720 divide 6 is 120. This is your X bar. You need to calculate because it's not given in the question. Okay, so continue to find the S standard deviation. So use the formula of ungroup data. The formula is square root 1 over n minus 1 in bracket sum x square minus sum x square over n, close bracket. Okay, so square root 1 over n minus 1, 6 minus 1 is 5. Okay, sum x square. Sum x square means total x square. So you need to calculate the total of the x square. So how to calculate is 110 square plus 118 square plus 110 square until here plus 150 square. So find the total for the x square. Okay, after you done calculate, the answer is 87608. Okay, minus sum x here 720, you square and then divide n is data n. Data your n is 6, close bracket, and then you calculate, and the final answer for standard deviation is 15.54. Okay, so finish to find the x bar and the standard deviation S here. Okay, so we continue to hypothesis test HO and H1, H0 and H1. Okay, so at 1% significant level, are the undergraduate students smarter? Smarter means more than or less than. Smarter means more than. So your mu here is more than. This one for H0 is equal. Okay. Smarter than the population average. Okay, what is the population average given? Okay, the population average given is 100 points. So equal to 100 here. So 100, more than 100. Okay, continue to the significant level. Okay, significant level is the value of alpha given. It given for 1%. 1% means 0.01. Okay, next I continue to test statistic. Okay, so the test statistic, okay, using the t equal to x bar minus mu, okay, over s divide square root n. Okay, the x bar you done calculate before, the answer is 120 minus mu. Mu here 100 and the s, you calculate the s is 15.54, okay, divide square root n. The data is 6. Okay, calculate. So the final answer is 3.15. This is the test statistic. Then continue to the next step is the critical value. Okay, critical value means the T alpha n minus 1. So T 0.01, the alpha given, and the n minus 1. You have data n equal to 6, but you need to minus 1. So 5 only here. So T 0.01 and 5, you read from table T. Okay, 0.01 here and the value of 5 on your left here. So the answer is 3.365. Okay, 3.365. Okay, and then you must give the symbol here. This is more than, so the value must be positive. 3.365. Then we make a decision rule. The next step. Okay, when you reject hash null, you reject hash null if T calculate more than T table. T calculate more than. Why more than? Because your hash 1 is more than. Okay, this is the decision rule. Okay, then we make a decision by comparing the value of T calculate and the T table. Okay, so decision. Okay, T calculate 3.15, T table positive 3.365. Okay, 3.15 is more than or less than, this is less than. So you do not reject hash null. Okay, do not reject hash null. Okay, so if you do not reject hash null, you can make a conclusion that conclusion, do not reject, so there is no sufficient evidence to conclude that the undergraduate student smarter than the population average. Smarter than population average. Okay, so complete for example 3. Okay, and then you have another 2 example, example 4 and example 5. You try by yourself. Okay, thank you class.